So, I hope everyone is well. We are going to start with a word of prayer. Let's get someone to lead us in a word of prayer. Yes, Daniela.
Okay, let's have ourselves for word of prayer. King of Kings, we thank you for this day. We thank you for the gift of life. We thank you for the chemistry lesson that you're just going to have. King of Kings, may you please help us understand whatever they're going to teach to us, and may nothing go wrong. May the network be okay. In the mighty name of Jesus, we have prayed. Amen.
Amen. Thank you so much, Daniela, for that wonderful prayer. So, maybe as the lesson goes on, you could share with me some of the topics you covered last time. But basically, today we are going to look at the first topic of second term. Some of you, if you moved very fast, you may have covered it, and some others may not. So we are going to begin with that topic. And that topic is carbon in the environment. So we know that every time we're beginning a new topic, we expect to know the competence and then the learning outcomes. What are those things you're expected to know as we study this topic? And what are some of those things that you must know at the end of the topic? So that means as we go through that topic, these learning outcomes should keep reoccurring back to you to ask yourself, have I actually understood this part? So that is something we are going to do. So I'm going to request someone to raise their hand so that they can read for us the competence and the learning outcomes. Nasana, maybe you could unmute, then ask someone to unmute, then you say their name such that it's easy for them to unmute and read.
Victor, could you please read for us? Victor? He's gone off.
Okay.
Consolate.
Good afternoon.
Good afternoon.
The competence is the learner investigates the diversity of carbon compounds in the environment. Learning outcomes. Learning outcome A. Understand how and why carbon compounds are used as fuels. Know and appreciate the difference between renewable and non-renewable fuels are not sustainable. Know and appreciate the impact of burning carbon-based fuels on the environment. Understand the process of making charcoal, but recognize that the use of charcoal as fuel is cheap, efficient, and sustainable only if it is made from wood that can be regrown easily.
Okay, thank you, Victor. Let's have someone else to read for us the next learning outcomes.
Consolate, could you please read for us? Okay. Consolate has gone off. Then Esther. Esther, please unmute.
Part A, know and appreciate the physical properties and uses of carbon dioxide. Part F, understand how the increase in carbon dioxide in the air can cause the atmosphere and the oceans to get warmer. Part G, understand what greenhouse gases are, where they come from, and how they are affecting climate. Part H, understand the origin of hard water in limestone areas and investigate how it can be softened. Part J, understand how the properties and uses of the allotropes of carbon relate to their structures.
Okay, thank you, Esther. So when you look at those learning outcomes, they are quite many, but they are showing us what we are expected to cover as we go about this topic. So I'm going to request that we restrict the chat to what we are learning such that we don't keep sharing halos and highs as we go about the lesson. So let's keep it content related. That means you post maybe responses to what we are sharing or a question such that we don't have a lot of chats that have halos and WhatsApp and which school you're from. So we can do that after the lesson. So we are going to be looking at carbon in the environment. And of course, we know there are different substances in our environment that contain carbon, actually several of them. These images are just showing a few of those components that have carbon in them, but we know that all around us, most of the things we interact with on a daily actually contain carbon. So what do you know about carbon in the environment? What are those thoughts that come to you when you hear carbon in the environment?
Victor? Anyone else?
You could check the chat as well in case anyone has shared any thought.
Consulate has said gases.
Okay.
Vanessa says gases in fire extinguishers. Seth
Okay.
says helps in many processes. And Karen says fuels.
Okay, thank you so much, Angel. Thank you so much, all of you, for your responses in the chat. So I love those ideas, the fact that you know some of the gases combine with carbon in order to form different other gases. And then, of course, understanding the fact that we are looking at the different processes that involve carbon. And then gases used in the fire extinguisher. Elijah, we are not covering a topic you've covered. That's why it's a general topic for all of us because all of us are coming from different schools. So I can't pick a topic that all of us have done. That's why I mentioned at the beginning of the lesson that I am beginning with a term 2 topic. That means carbon in the environment is the first topic of term 2. That means we are all sharing from a level of understanding each other. That means I expect all of us to collaborate because even the ones giving suggestions, I don't think have looked at this topic. Yeah, so carbon in the environment, of course, you need to understand what is carbon. For those of you that had looked at the periodic table, you realize that carbon is one of the elements in the periodic table. And we know that it's the sixth element in the periodic table and it belongs to group 4. But if you've not yet reached there, when you get there, when you go back to school, you'll be able to reconcile the knowledge of what I am sharing. So carbon, like I said, is found in most of the substances that we interact with all the time. So of course, carbon is the fourth most likely abundant element. That shows how abundant it is because we have over 100 elements. So being in the fourth position shows that carbon is one of the most abundant elements. And of course, it's a building block of life because even in our bodies, most of the cells, most of the bones, the hair, you realize that they are made up of what? Of carbon. So, like I said, carbon is the sixth element in the periodic table and it is a non-metal. So of course, like some people mentioned that when they hear the word carbon in the environment, they think about gases. So when we burn carbon in air, we expect that it's going to form gases. And these gases depend on the amount of oxygen that we burn that carbon with. For example, when we burn carbon in less oxygen or little oxygen, that means we are going to form carbon monoxide. But when we are looking at carbon burning in excess amount of air, it's going to give us a common gas that all of us can relate with, which is carbon dioxide. So in limited supply of air, when I talk about limited supply of air, that means in limited oxygen. Carbon burns with oxygen to give us carbon monoxide. Carbon monoxide. Whereas in excess supply of air, it's going to burn to give us carbon dioxide. So that means the more you burn these carbon components, the combustion of fossil fuels to some extent has increased the amount of carbon dioxide in the air. So we know that all these fossil fuels actually contain carbon. So that means if we burn them, because combustion is about burning a substance in air. So if we burn them in air, definitely they are going to form and increase the amounts of carbon dioxide because we know the atmosphere is made up of a given percentage of of carbon dioxide, which is 0.03%. But that percentage is increased depending on the rate at which these fossil fuels that contain carbon are what? Are burnt. So I hope we are on the same level. And I want you to have that at the back of your mind. If you actually have a book, which you should have, you could write down those equations whereby we say in limited oxygen, carbon burns with oxygen to give us carbon monoxide, while in excess oxygen, carbon burns to give us carbon dioxide gas. So I hope that is clear. Moving on to the next, we know that carbon has processes in which it is it's used up and then remanufactured, then used up again and then remanufactured. So we all know that as human beings, we breathe out carbon dioxide and breathe in oxygen. So this carbon dioxide that we breathe out is needed by some other living organisms. But then for us, we are giving it off. And then some of those organisms are giving off the oxygen that we need. So it is more like a cycle. And when we are looking at a cycle, it means these processes depend on each other and they do not end. It is a continuous kind of thing. As this one gives off, the other one is giving off, and then the process continues. So a carbon cycle contains all the processes in which carbon dioxide is added and removed from the atmosphere. So here we have the carbon cycle, we have carbon dioxide. So carbon dioxide is produced from plants when they're when they're undergoing photosynthesis, they require that carbon dioxide, and that is what we are seeing here. Of course, in the presence of sunlight, the plants are photosynthesizing, and of course, there is decaying and organic organisms which are giving off that carbon dioxide, burning of fossil fuels, and then of course we have the auto and factory emissions which give off carbon dioxide as well. And then we get back to the carbon dioxide, which is still then absorbed by the plants, and then like that. So these arrows, this one is showing a sheep here. So the animal here is giving off the carbon dioxide. Then the plant during respiration is also giving off carbon dioxide. So that means at this point, we understand that a carbon cycle is made up of those processes in which carbon dioxide is being used and then how it is being produced. So they are interconnected. They all depend on each other to produce and also to use up that carbon dioxide. People, is that clear? Okay, so we understand that the carbon compounds exist as fuels. Yes, Jerry?
Excuse me, teacher.
Mm,
Teacher,
yes, please.
you're somehow too fast.
Oh, so can I go back to the previous slide?
Yes.
Okay, thank you. So what do I need to re-echo on this slide?
The around from I got lost.
Okay, your network is not very stable, but when we talk about the carbon cycle, first of all, I want you to understand what is a cycle. I know in primary you looked at the different cycles of um, of the insects, whereby you're looking at from the eggs until they form the adult stage of that insect. So it's the same thing, because when this adult insect develops, it's also going to lay eggs, and the process will continue again. So when we are talking about a carbon cycle, we are looking at those processes that involve the addition or removal of carbon dioxide from the atmosphere. So if I could ask a plain question, you will ask yourself, what are those processes in everyday life that give off carbon dioxide? So those processes are the ones we have detailed in this cycle, that these given processes produce carbon dioxide. But then the carbon dioxide that is produced is also important to some other organisms. That means the one that has been produced is now used up by other organisms that actually need it. That is to say, for example, we have animal respiration. That means when animals breathe in and breathe out. I want you to follow my cursor. So here, the diagram may not be very clear because of the resolution. So here we have the animal. This animal is giving off carbon dioxide. And when it dies, it's going to decay still to produce carbon dioxide. But this carbon dioxide that is being produced here is going through the process that continues this side. So when we have carbon dioxide, we all know that some of the conditions responsible for photosynthesis, the person talking, please mute because you You're interrupting unless you're asking a question, because I'm getting a lot of echoes. So I was saying some of the conditions responsible for photosynthesis to take place is sunlight and then carbon dioxide. So that means the carbon dioxide that is being produced here is used by the plants. And after the plants have used that carbon dioxide, they're going to produce food and eventually will decay. So that means the animals and the plants decay, producing more carbon dioxide. And this process is continuing to the fact that also industries and factories give off carbon dioxide. Those are the ones we are calling auto and factory emissions. And then that carbon dioxide that is given up at those different stages comes back to the carbon dioxide that was initially used up. So that's why I said it's a cycle. It keeps rotating about itself. As the carbon dioxide is used by the plants, it is being produced by the different processes. People, is that now clear?
Yes.
Okay, thank you for that response. So the carbon cycle, you basically have to just know what is happening during the cycle. Yes, Joel?
Teacher, I just wanted to know that is it true that during at night, like plants like release carbon dioxide?
Yes, because they are respiring. So that means at night, since there is no sunlight, they are able to give off what? Carbon dioxide. At that point, they are respiring, like how living organisms do.
Yes. Thank you.
Okay, so let's continue. And Joel, thank you for that question. That's why you see that here we have plant respiration giving off carbon dioxide. So at night, they are able to respire and give off carbon dioxide. Okay, if we are all there, I would want us to move to the next slide. So here we are looking at the carbon compounds used as fuels. I want someone to raise their hand and they tell us the names of these different fuels. Maxwell?
Mildred.
The first one is a kerosene lamp. Then the second one is a generator. Then we have wood and electronic, the vehicles.
Okay, thank you. So each of these elements is made up of, is a fuel. So that means the fuel that we are using in these different items is a carbon compound. So for example, Maxwell said this is a kerosene lamp. That means kerosene is a carbon compound used in kerosene lamps in order to produce light or heat. And then, of course, when we look at the generator still, it may be a diesel generator, it may be a petrol generator, depending on what kind of fuel it is. And then, of course, we have wood, which is also made up of carbon. And then we have the car, which uses the different carbon components, which may be diesel or petrol, depending on which. And they all have various purposes that they serve, depending on what you're going to use them for. So those are some of the carbon-based fuels. And then we have the carbon-based compounds as fuels. Does anyone have an idea on what fuels are? Because I've kept mentioning fuels. Who can share with us their thought about fuels? Anyone to share with us any idea you know about fuels?
Fuels are energy sources consisting of carbon and hydrogen atoms.
Okay, thank you. That is good. Angel, please, when you request someone to unmute, ensure that you unmute and mention their name. It will save a lot of time. Okay, here in the chat, I have a fuel is a substance that burns to produce heat and light. That is good. Thank you, Augusto. Let's hear from Say.
Fuels are substances that produce heat and light energy after burning.
Okay, that is
when burning
good.
as well, yes.
That is good. Thank you. Victor.
Fuels are materials that can be made to react with other substances so that they can release energy.
Okay, that is good. Thank you. Mildred.
I had already answered.
Yeah, but your hand
Okay,
is still up.
sorry.
Okay, Consolate. Okay, let's hear from Jesse.
Sorry, teacher, I went off for a while.
Elijah.
Yes, please.
Yes, Elijah. Okay, I don't seem to get feedback from you. Okay, so fuels, like everyone else has said, are substances that react with oxygen during combustion to release energy. And that energy can be heat or light energy. So when we burn these substances, definitely it's more like reacting them with oxygen. And through that process, they're able to release useful energy. So what are some of the examples of fuels you use at home? What are some of the examples of fuels you use at home?
Mildred, your hands up, please.
Charcoal.
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 Thank you.
Maxwell?
Paraffin.
Yes, please.
Okay, that is
Paraffin. Firewood.
Thank you.
okay. So thank you for those suggestions. So, of course, most of the fuels used at home, paraffin, kerosene, you use firewood or charcoal. So all those are various fuels that we use at home. So most of the fuels used give off a lot of heat or light when burnt in air. So the people that complained I'm fast, I hope I'm not too fast now. So when I'm fast, you please let me know such that I can slow down. So Esther, the definition of fuels is on the screen, so you can read it from there. So we have most of the fuels give off a lot of heat or light when burnt in air. So that means fuels are expected that when we burn them in air, they can give us both. Some of them will give us both light and heat, while some will give us light. And basically, maybe the use of that particular one is for lighting, while some can basically do both depending on the environment you're in. So what do we observe when you burn wood and peppers? What do you observe when you burn wood and peppers?
Maxwell, could you please unmute and tell us? Maxwell?
When we burn the wood and peppers, they produce light, energy, and the heat, and later they turn into ash.
Okay, thank you. That is good. Any other suggestion? I'm seeing in my chart, smoke, ash is formed. Thank you, Agusu and Karen, for those responses. So you're going to notice that when you burn wood and peppers, there is one thing that is common for both of them. Heat is produced. And because heat is produced, of course, they are going to burn to produce an end product, which could be black. So the wood burns to give us black, black charcoal, or the peppers burn to give us something that is light black that people may call gray. But when you look at that ash produced by peppers, it's basically black. So that shows the existence of carbon in these compounds. So when we burn wood and get that black substance, it's proving to us that carbon got burnt in that substance. So that proves the existence of carbon in some of the substances that we interact with every day. I hope that is clear. So we are also going to look at renewable and non-renewable fuels. So this diagram is not so clear, but I'll read for us what these diagrams are showing us. So for the renewable fuels, this side, I hope you can see with me. We have the renewable energy, this side. So it has the sun, which is the solar energy, which is produced from the sun. Then we have biomass, which comes from decay of living organisms. Then we have wind energy. Then we have geothermal energy. then we have hydropower energy. So we are going to look at those in detail. I'm just showing us because the resolution of the diagrams may not be so clear. And then of course we have the non-renewable energy. The non-renewable energy has fossil fuel oil, then we have coal, then we have natural gas, then we have nuclear energy. So those are some of the examples of these renewable and non-renewable fuels. So I want you to familiarize yourself with these images, and as we go about the next slides, I will ask us some questions that I expect us to really have a clue about. So what are renewable fuels? According to the description of the diagram we had up there, what do you think are renewable fuels?
Anyone having an idea? Mildred again. Oh,
A renewable fuel is a fuel that can be replenished naturally over time, typically from natural resources like firewood and charcoal.
thank you, Mildred. Does anyone else have another idea? Vanessa, please unmute and tell us.
Um, According to me, I think a renewable fuel is a fuel that can be naturally replaced even though it's being used up.
Thank you. Any other person with a different view? Sauda Nansuga, please tell us what you think.
Good afternoon.
Good
I
afternoon.
think that renewable fuels are fuels when used up and exist naturally.
Thank you.
Okay, thank you all for those contributions. I think we'll have those for now. And in my chart, I have that can be replaced once used up, fuels that don't get depleted. Renewable fuels are fuels that are replenished at a high rate than they are consumed. Then they exist on their own. Okay, these are all good suggestions. So that means when we are looking at renewable, that means we can get something back. Renewable. So when we are looking at renewable fuels, those are fuels that can be replaced or replenished once used up in a shorter period of time. So that means when we are having these renewable fuels, we expect that we can have them back in case they are used up over a relatively short period of time. This is short, not short. Sorry about that error. So we have some examples of renewable fuels. Can we mention some examples that we know?
Mildred, once again, your hands up. Could you please tell us what you have? Okay.
In the chat, I have wood.
Victor, please tell us.
Wood.
Thank you. Any other ideas?
I'm seeing someone has posted rocks. Rocks are renewable resources, not fuels as per se. So I mentioned them in the slide above. We have the different renewable fuels, and one of those we have is the wind energy, solar energy, geothermal energy, hydropower energy, biomass energy. And one thing you're going to notice about all these, they are basically naturally made. When you look at the wind, you don't have to persuade yourself to produce the wind. The wind naturally exists. When you look at the solar energy, when you look at the geothermal, and then the hydropower, and then the biomass. So some of those are the examples of the renewable fuels. Okay, so we move on to the next. What are some of the advantages of renewable fuels?
Um, Elon, your hand was up first. Please tell us. Elon. Elon is not unmuting. Me too, Lawrence. Please tell us some of the advantages. Okay.
Advantages of renewable fuels, they are non-polluting to the environment.
Thank you. Any other ideas? Anyone else? Me too, Lawrence. He's gone off again. We have, who else is here? Maxwell.
They are easy to get.
Okay. Michaela. Michaela.
This is Vanessa.
Okay, Vanessa, please tell us. Yes.
It is cheaper. It's cheap to use than other sources, other fuels. Excuse me.
Thank you. Seth? Seth, please unmute.
I want to say that they take less requirements to be maintained and stored. So basically, it makes it almost the same point cheaper. So yeah,
Could you come again, please?
they less requirements on no be stored and maintained. No, they don't need to maintain, stored, so less facilities and less money is used. So it's almost in the same point as cheaper.
Yes. Okay. Thank you.
Okay, so Angel, I think those responses are enough. And thank you everyone for your contributions. And thank you, Angel, for coordinating that. So in the chat, I have several of them. They're available, they're readily available in the environment, they generate no emissions, they are pollutant free. Yeah, so thank you all for your contributions towards the advantages of renewable fuels. So we have 4 of them here. Maintenance requirements are lower, so that means the maintenance expenses are quite low if you need to maintain them. And then of course they can be used over and over again. For example, if you're using solar energy, all you need is the sun. And then of course we have saves the environment by emitting little pollutants into the air. So the environment is saved from those pollutants that could likely be produced by other sources of energy. And then, of course, they are reliable sources of energy due to their availability. At least we know in the year the sun will shine more often. We know that in a year wind will be there. We know that in a year water will be flowing. So they are available within the environment. Then we have disadvantages. What are some of the disadvantages of these renewable fuels?
Michaela. Michaela, please unmute. Okay. Yes. Yes. Michaela seems to have gone off. Me too, Lawrence.
They take a long time to be renewed.
Micho, can you please unmute and say something?
Strong wind is
They take a long
destructant to
time
the
to be renewed.
environment.
Okay, thank you. Elijah?
Elijah.
Elijah, we can't hear you. I don't know if it's only me not hearing you. Let's hear from Seth. Seth, unmute.
They have geographic locations. The same way some countries don't have the physical features now to build dams, they don't have large rivers or water bodies. Some countries are dry, so they have some geographic limitations.
Okay, that is good. Thank you. Consulate. Unmute.
Consulate.
Okay, so let's take the ones in the chat. One has said the initial investment costs for renewable energy technologies can be high, although costs are decreasing over time. That is good. They can lead to soil erosion, wood, and have storage capabilities. I didn't get that, Timothy, but thank you all for your responses. So here I have two disadvantages. You can look for more after the lesson. So we have there is a high need for storage, and storage technologies are expensive. So that means if you're going to set up these storage buildings, they are going to be quite expensive. And also the materials used to capture the energy from those resources may be quite expensive. And then, of course, unpredictable weather events that disrupt the continuity of these resources. And then, like someone already said, the geographical location of some countries. So when you look at the unpredictable weather events that disrupt continuity of these resources, for example, if it chooses to rain for a whole month without the sun really being there, you're going to find that those using solar energy will quite find it hard. Okay, then for the non-renewable fuels, my battery is not at its best. It's about to shut down any minutes from now. So I'm going to request us to make some research on non-renewable fuels. You find out what they are, the examples of those non-renewable fuels, the advantages and disadvantages of those fuels. Then in our lesson next week, that is where we'll begin from. So my battery is low and there is no electricity this side. So I don't want the unexpected shutdown because in the next few minutes it will really go off. So I hope you've taken note of those. Find out what are non-renewable resources, sorry, non-renewable fuels, examples of non-renewable fuels. And then what are the advantages and disadvantages of those fuels? And if you're able, you can also post in the WhatsApp group your findings, and of course, you'll get a response from me.
Okay.
So I don't know if any of us has a question in the remaining minutes, such that I could take that question.
Elon, please unmute.
Elian, you can unmute.
Thank you very much. Master, Madam, I have a question. Of the two fuels, the non-renewable fuels and the renewable fuels, which of the two are readily available? Is it the non-renewable or the renewable fuels?
Elon, you give me the answer to that question when we discuss the non-renewable fuels. So please keep that question when we discuss them next week. You give me the answer yourself. Is that clear?
Okay, Master. Okay.
Okay, thank you everyone. Have a blessed day.